Electrical sources don't just create electricity out of nowhere. What they do is convert non-electrical energy like chemical, mechanical, or solar energy into electrical energy. Take a wind turbine for example. It uses the kinetic energy of the wind to spin a generator which produces electricity. That electricity is then sent through cables inside the tower and onto the power grid. From there, power transmission lines carry it to homes, businesses, and industries where it powers our appliances. These devices take that electrical energy and turn it back into other useful forms like light, heat, or motion. So really, the entire electrical system is nothing but one giant energy conversion process. So we can't create energy, all we are doing is converting other types of energy into electrical energy. And those conversions aren't 100% efficient. For instance, coal-fired power plants typically only convert 33 to 40% of the heat energy from coal into electricity. That means if you put in 100 joules of heat, you will only get about 33 to 40 joules of electricity. So if someone ever tells you they have invented a device that produces electricity with no fuel, now you know how to do. Now with that in mind, we often need to compare various electrical devices' ability to convert energy from one form to another. So we define the term electric power as the rate at which electrical energy is supplied or absorbed by an element, or simply energy transferred per unit time. So mathematically, we can write this as P equals to W by T. Now let's see how we can turn this power equation into a more useful form. If you can remember from the previous video, we defined voltage as the energy required to separate 1 coulomb of opposite charges. That is B equals to W by Q. We can rearrange this as W equals to VQ. So let's substitute VQ for W, and finally since Q by T is just the current, we end up with P equals to VI. So the power consumed or supplied by an element is the product of the current flowing through it and the voltage across its terminals. Electric power can flow either way, out of a device or into a device. In other words, a device can either supply power or consume it. To capture this idea mathematically, we need to introduce a sign convention. People choose power consumption as positive power. In literature, you will find this as passive sign convention. So for the electric sources, that is when a device supplies power to the circuit, the current comes out of its positive terminal. In this case, power is considered negative. And for positive power, current flows into the positive terminal of the device. For example, in this simple circuit, the battery is supplying power and this light bulb consumes it. So the battery's power is negative and the bulb's power is positive. Electric power is measured in joules per second and we call this unit a watt. So if you hear someone say a bulb uses 60 watts of power, that means it converts 60 joules of electrical energy into light and heat every second. And that's the basics of electric power, how it's calculated, measured and understood in circuits. Thanks for watching. I hope you have learned something new today. If you did, don't forget to give this video a thumbs up and consider subscribing to the channel for more content like this. Share it with anyone who might find it helpful. You can grab the note link in the description. And if you need extra help or just want to support the channel, please become a Patreon member. Your support means a lot. See you in the next video.